Anybody have anything you'd like to go over? Again, go over to the meeting chat and let us know. First one out of the get-go. No, I messed this up last class. I mean, this is the right section. This is what we're on, right? Yeah, I'm pretty sure this is 5. Let's start with number 19. Now our directions here, first of all, asked us to find all of the solutions, and then for part B, just list the ones that are in that specific interval between 0 up to, but not including 2 pi. All right, so again, we're going to start off with our lovely algebra here and isolate the variable term. Do a little bit of division, get rid of the coefficient. Now, usually at this point, we would then proceed and take the inverse cosine of both sides. So let's see, the value for cosine is negative in quadrant 3 and in quadrant 4. Okay. But again, if you take the inverse cosine of both sides, the inverse cosine of cosine 2 theta is going to be 2 theta, not just theta. Okay. And we'll take care of that issue as the very last thing we'll do here. Okay. From our handy dandy note card, we know that cosine is equal to positive 1/2 at pi over 3. So now, again, for the negative, we're going to use pi over 3 as our reference number in quadrant number 3. That should give us, let's see, so we'll take pi and add pi over 3, so that'll be 4 pi over 3. And again, plus our standard plus 2k pi. No, I'm sorry, cosine. Yeah, you guys, you can come off of mute, you know. Sorry, I'm sorry. Sine is negative in quadrants 3 and 4. Cosine is negative in quadrants 3 and 2. All right, that's better. Again, pi over 3 is our reference number. So for quadrant 2, taking pi minus pi over 3 should give us 2 pi over 3, again, plus the 2k pi. So again, we write out those expressions there based on, okay, where can we find angles, and then the repetitions, the multiples of those angles, where this function has this value, okay? And then the last thing that we need to do here is do the dividing, because that's not the angles we were exactly looking for. It's 2 times the angles we're looking for. So then we can transform both of these and say, well, half of 4 pi over 3 will give me 2 pi over 3. But again, divide everything, so then that's going to be just times k pi. And then for the one in the second quadrant, well, half of 2 pi over 3 becomes 1 pi over 3. Again, divide by 2 plus k pi. So those are the expressions that we need for, again, all of the solutions. So that's for part A. For part B, they wanted you to list all of them in that particular interval. Well, okay, so if we put in 0 in place of k, we're going to get pi over 3 from my second expression, 2 pi over 3 from that first expression, because I did it backwards. That's all right. If I put in 1 in place of k, so it's pi over 3 plus 3 pi over 3, so that'll give me 4 pi over 3. And then 5 pi over 3 from the first one. If I put in 2 in place of k, well, obviously adding the pi over 3, it goes beyond. They said this interval is only supposed to go from 0 up to, but not including 2 pi. So here is the complete list of solutions for part B. Anybody have any questions with 19? Okay, let's take a look at 41 then. All right, now they gave you the little suggestion here about doing a substitution because we have basically two different issues. Again, we're trying to solve this equation. We're trying to find the values for theta that make this a true statement. All right, one issue is the fact that we've got two different angle measures. We've got theta and 2 theta. Second problem is the fact that we have two different functions here. Okay, so what's on the left-hand side here is quite a mess. They are suggesting, and again, hopefully this popped into your head, maybe. It should look somewhat familiar to you here. Let's, on the back of your note card, let's take a look at sine of one angle times cosine of a second one minus the product of cosine times sine. Okay, so hopefully you can see how that matches up with our difference formula for the sine function. Okay, so again, the way that I wrote it down, sine of x minus y is equal to sine of x cosine of y minus cosine of x sine of y. Okay, and again, that was one of those, that might have actually been section 2 or 3. Now, I think it might have been 2. There were so many of them in section 3. So again, our difference formula here for sine, notice how that matches up, sine times cosine minus cosine times sine. It happens every single day. Oh well. So we can then turn this into, this is equal to the sine of 2 theta minus theta. That's equal to square root of 3 over 2. And my, how convenient is that? Because simplifying what's on the inside of the parentheses becomes theta. Again, if you knew that substitution, if you were aware of that identity, Oh my goodness, that becomes really, really simple now. Okay. So again, take the inverse sine of both sides. So theta is equal to square root of 3 over 2. And again, it's our sine function. That happens at pi over 3. Again, sine, I'm going to pay attention this time, I promise. Sine function is positive in quadrant 1. Okay, so that's our pi over 3. And in quadrant 2, so that'll give us 2 pi over 3. And then we'll go ahead and add absolutely nothing, because again, the second part of the directions here, again, they gave you a clue. Use that formula to simplify, but then find all the solutions in this interval between 0 up to, but not including 2 pi. I don't need those expressions for all of the solutions. There are only 2 of them in that interval. That's where we stop. Again, we're not going to find something in quadrant 3 or quadrant 4 because sine in those quadrants is negative. Okay. 41 making sense? Find that unmute button. What happens here? Some of you are still there. Mr. Meister doesn't like to use his camera. Oh, whatever. 55 is next. Isn't it nice that they're giving you these little hints? This one, they suggested that you use one of our sum to product formulas. All right, so cosine plus cosine. Really? That's going to be helpful? All right, fine. Well, we will get this down from 2 different terms on the left down to just 1 term. Well, it's going to be a product. All right, well, it was their idea. Let's go for it here. So x plus y over 2, so that'll give me 4 theta plus 2 theta over 2. Then multiplied by the cosine, I have to take the difference. 4 theta minus 2 theta divided by 2. Still an equation, still equal to cosine. So 4 plus 2, that'll give me 6 divided by 2, that's 3. So 2 cosine 3 theta times the cosine 4 minus 2, that'll give me 2 theta divided by 2 is 1 theta. Really? This is an improvement here? Now again, if I have 2 terms, how about I, at the same time here, subtract cosine of 1 theta from both sides. Set the equation equal to 0. Because again, I have a product here of 2 trig functions. I consider that to be quadratic. Okay, if that said x times x, if it times y, it's a second equation. And again, we've talked repeatedly about solving a quadratic, a second degree equation. You set it equal to 0. You factor it, set each factor equal to 0. Go through that process. Well, okay, it doesn't look all that pretty at this point. Had we not done this substitution here, cosine 4 theta plus cosine 2 theta minus cosine 1 theta equals 0, there's nothing in common to factor. Here, since we've done that substitution, we have cosine theta as a factor in both of the terms. Now again, the one's more complicated than the other, but we really have two terms on the left-hand side. A common factor that I can take out is cosine theta. So factoring is dividing. So 2 cosine 3 theta times cosine theta divided by cosine theta will leave me with 2 cosine 3 theta. Cosine divided by cosine is 1. It's still an equation, still set equal to 0. Okay, so I've set it equal to 0. I have factored it. Now I get to set each factor equal to 0. So cosine theta is equal to 0, or 2 cosine 3 theta minus 1 equals 0. Sorry, let me check. Yeah, the directions just say solve the equation. They did not give us any kind of restriction here for a particular range of values. All right, so where is cosine equal to 0? Well, that happens when, oops, move it down here. So again, cosine starts at its maximum there. For 0, it's at 1. It comes down to 0 at pi over 2, down to the minimum at pi, back up to 0 at 3 pi over 2. So there's part of our solution. Now with the second part of it there, okay, again, do the algebraic part of it. Add 1 to both sides, divide by 2, so we should get it down to cosine 3 theta is equal to 1/2. So now 3 times theta, where is cosine equal to 1/2? So that's at pi over 3. And again, we add the 2k pi. And cosine is also going to be positive in the fourth quadrant. So 2 pi minus pi over 3 should give me 5 pi over 3. Again, plus pi. But again, from my second factor, that's not what theta is. That's what 3 theta is equal to. So yay, divide everything by 3. Well, pi over 3 divided by 3 should give me pi over 9. Two k pi over 3. Now again, nothing reduces there. So I would say let's just, if we're leaving this value in fractional form, we can leave the second one the same. Okay, or theta is equal to 5 pi over 9 plus 2k pi over 3. Not pretty, but accurate. Okay, any issues on that? That was interesting. All right, let's go to, yay, the hours of daylight. Yeah. In order to make it into a cyclical function here, we're going to have to do a little bit of interesting definitions. So in Philadelphia, again, this is dependent upon latitude and longitude, I do believe. The number of hours of daylight is modeled by this function. Oh, isn't that just so lovely complicated there? Yeah, don't get too intimidated. It's a sine function, okay? Here's the tricky part. T is defined as the number of days after January 1st. So which day of the year it is. We can't put in September 23rd in place of T. Okay. For part A, which days of the year have about 10 hours of daylight? So 10 is the number of daylight hours. We're going to take the equation and set it equal to 10. Isn't that fun? Well, all right, so we're going to do a little bit of, do the algebra stuff here first. So I'll subtract 12 from both sides. So that should give me -2. Then we're going to divide both sides by the 2.83. So say we go to the calculator here. Doesn't like the touchscreen. -2 divided by, again, that coefficient was 2.83. Now again, my denominator's larger than the numerator, so yay, something that's less than 1, but again, it's negative. All right. 7067. So we've got it down to our sine function is on one side of the equation, and we have a value there on the other where we could take the inverse sine of both sides. So that's exactly what I'm going to do. I need the inverse sine. Oops, nope. Okay, yeah, stop it. A thought just crossed my mind here. If I change my document here into degree mode, yeah, I know you guys are going to ask that artillery question here in a little bit, so maybe I just jumped the gun on that one. Okay, so that's in radian. Maybe we should leave this in radian. Sorry, that was not a. I took you down the wrong path on that one. So negative 0.7848. 48 is pi over 365 times t minus 80. Okay, again, we're trying to solve it for t. So we need to get rid of the lovely coefficient there. So I say we can multiply both sides by the reciprocal, 365 divided by 2 pi. And again, that's still going to be negative. Now I want to make sure that I'm dividing it in parentheses there by 2 pi, or I could just do that in two separate steps. I don't want to type in my answer divided by without the parentheses. It'll take this answer and divide it by 2 and then multiply it by pi. That's order of operations. Okay, so that gives us negative 45.59 blah, blah, blah. Forgot what I did, the blah, blah, blah part of it, 0.59 is to t minus 80. So now I just add 80 to both sides. Philadelphia is going to get 10 hours of daylight on, I would say we have to round that to day 35. Okay, if I round that off on day 34, I'm saying this is probably going to give them just a little bit under 10 hours of daylight. So I'm disagreeing slightly with what's in the answer key there of your book. I'm saying this happens when t is equal to, again, this is the day, so the 5th day of the year, which turns out to be February the 4th. Does that make sense? Do you guys know the whole knuckle thing there about how many days are in each month? Okay, so the 35th day, January has 31 days. So that puts it at February the 4th. But wait, there should be a second answer, shouldn't there? Again, it's cyclical. How much do you guys pay attention to the summer solstice, the winter solstice, the spring equinox, and the fall equinox? We're still in this cycle that started back in June. The number of hours of daylight is getting shorter and shorter and shorter, and it will continue to get shorter until right around Christmas time. Then we have the winter solstice, and from that point on, the number of hours of daylight starts getting greater and greater. It amuses me when I hear people say, oh, the days are getting shorter. No, they're not. They're all 24 hours long. Stop saying stuff like that. What you mean is the number of hours of daylight. So if there is a day here in February where there are 10 hours of daylight, there should be a corresponding, could we actually think of this as a graph? The number of hours of daylight, I'm sorry, never quite gets down to 0 in Philadelphia or here in Southwest Ohio. You have to go other places for that. Again, if time 0 here is January 1st, well, that smallest number of hours of daylight is the winter solstice here, and it starts increasing, and then we get to the summer solstice where it's the highest, and then it starts decreasing again, and again, 1 full year. So there has to be light. There has to be a point here, and there has to be another point there where it's equal to 10. Okay, so we found the first one there as the 35th day, and then translated that into our calendar there for February the 4th. But now we have to find the other one. Now, again, that's going back to this value right here. Okay, so our sine is a negative 0.7076 in the third quadrant and the fourth quadrant. Okay, so I'm saying the 0.7848, that would be a fourth quadrant angle. Now we need the corresponding third quadrant angle. And then we're going to have to deal with the messy numbers there. So let's see, for something in the third quadrant, we're going to take pi and add the, again, our reference number here is going to be the positive of 0.7848. So 2 pi over 365 times t minus 80 could be equal to pi plus 0.7848. Okay, so this is quadrant 3, where sine is negative, and this is a representation of the angle in quadrant 4, where it's also negative. Well, it's the same kind of messy numbers there. So our other day turns out to be, and again, I slightly disagree with what's in the answer. I think we have to round that off to 309. Sorry, that's a 0. Which turns out to be November the 5th. So once you can get those two, boom, boom, here's our answers. On which days? There was a little clue there that it didn't just want one answer. Okay, it was plural. So again, because of the cyclical nature of the number of hours of daylight that we have here in the Northern Hemisphere, as long as you don't get too close to the Arctic Circle, you're fine. It'll change. So there's a big stretch of the year between February the 4th and November the 5th where we have more than 10 hours of daylight each day. So then for part B, it's just a matter of finding out how many days between that. I believe that works out to be about 275 days. Now, here, get used to it. This is life. Life is a word problem. Suck it up and deal with it here. Not everything is going to turn out to be nice and pretty. The numbers are going to get, life is messy. The sooner you can accept that as reality, the better off you're going to be and the better prepared you're going to be to deal with it. There, that's your wisdom for the day. See, this is the point where I should see this look of gratitude on all of your faces, and I'm again seeing a whole bunch of ceiling fans. Muddy Dog, does that get your attention back again? Oh my goodness. Okay, Mark's laughing. Jay's laughing. Aubrey looks slightly amused. We'll take that. Do we have time for the quiz? The answer is no, obviously. So let's talk about, yeah, did you realize our next meeting will be a week from today. Next Tuesday actually turns out to be December the 1st. Yes, we're now going to be in December. If we really absolutely need to, we could take a little bit of time next class. If you have more problems that you want to go through, I imagine somebody was going to ask about, what was it? Yeah, 63, the firing of the artillery. Come on, up. What are you doing? Oops. Yes, I know. You're so excited. You just woke up from your nap. You're fine. Tell them Happy Thanksgiving. I don't know what Thanksgiving is. So we'll take a little bit of time to, if you have last minute issues there, we'll do the quiz next time. Again, it's just over sections 4 and 5 with solving equations. I'm not going to give you the hardest things on the planet, okay? I want to see how you're doing. And that brings us to the end of chapter 7. So after that, it's going to be doing new problems and trying to get you ready for that chapter test. Okay? Does anybody have questions? Issues? Problems?
No.
Okay. Yeah, Adam, I can see the top of your hoodie there, but thank you for responding. All right, looks like somebody needs to go outside and get some lunch. Lunch is always good, right? All right. Be safe, be smart, take care, enjoy your very small Thanksgiving get-togethers, and I'll see you guys next week. Merry Christmas. Let's see. Are we doing that? There we go.